This video is on volumes by cylindrical shells. In the disk method, the axis of revolution had to be adjacent to the region being rotated, and it was the axis of the independent variable. In the method of cylindrical shells, the axis of revolution might be separated from the region being rotated and is the axis of the dependent variable. There are some circumstances where vertical or horizontal slices become problematic or impossible to use. The shell method offers something to fall back on when the washer method fails. Consider the region bounded by the functions y equals 4x minus x squared and y equals x. We can use the washer method to find the volume of the region revolved around the x-axis, but trouble occurs if you try to make horizontal slices for values of y greater than 3. When the thin vertical slices are revolved around the y-axis, a shell is formed. The shell is like a shell for a gun shell, not a seashell. It's cylindrical type shell as shown below. When the shell is cut open, a lamina is produced. So now, for example 1, they ask us to find the volume of the solid of revolution for the region bounded by the given functions revolved around the y-axis using cylindrical shells. So what we're going to do is we're going to take our function and we're going to go from 0 to 3 of 2 pi x, and then it'll be our outer function, kind of like in the washer method, minus our inner function, but we don't square them here. We combine our like terms, pull out our 2 pi, given that it's a constant. We end up with 3x minus x squared dx, integrate, and we get 2 pi 3x squared over 2 minus x cubed over 3 from 0 to 3, and we would get a volume of 27 pi over 2 units cubed. Just like for the volumes of other cross sections and disk method and washer method, we've got certain formulas that we need to follow. In both cases, we are going to have 2 pi as our constant. Depending on if it's a vertical axis of revolution, our volume will be in terms of x, or if it's a horizontal axis of revolution, then it'll be in terms of y. So for the next example, they want us to find the volume of the solid of revolution obtained by rotating the region bounded by the curve y is equal to x squared and the lines x equals 1, x equals 2, and y equals 0 about the y-axis. So now we're going to go this way, and we're going to take the region bounded by 1, bounded by 2, going about a vertical axis of revolution. So it'll be from 1 to 2, 2 pi x, the function is x squared dx. Pulling out the 2 pi from 1 to 2 of x cubed dx, we then get 2 pi x to the 4th over 4, evaluated from 1 to 2, and we get a volume of 15 pi halves units cubed. And for our last example on volumes using cylindrical shells, they want us to find the volume of the solid of revolution obtained by rotating the region enclosed between y is equal to 2 over x and the line x plus y is equal to 3 about the y-axis. So again, it's a vertical axis of revolution. If we solve this for y, we get y is equal to 3 minus x. So we've got a line. 2 over x is a rational function, but we're only looking at a part of it. So they want this region revolved around the y-axis using cylindrical shells. Well, just like with washer method, we've got an outer function and we've got an inner function. Our outer function in this case is our line, and our inner function is the rational function. The only difference with this and cylindrical shells is we're not going to be squaring our functions. So V will equal to 2 pi, which I've pulled out from 1 to 2, because those are the intersections of the intersection points of the functions, of 3 minus x minus 2 over x dx. I forgot the x on the inside. We need to distribute that in. So 2 pi from 1 to 2 of 3x minus x squared minus 2 dx. If we now integrate, we get 2 pi 3x squared over 2 minus x cubed over 3 minus 2x. From 1 to 2, we would get a volume of pi over 3 units cubed. I hope this video has helped with finding volumes of regions using cylindrical shells, and I shall see you soon.